When NASA's early warning systems picked up a faint change in the trajectory of the interstellar object known as 3I Atlas, no one in the control room expected anything unusual. It was supposed to be another visitor from the outer edges of our solar neighborhood, a chunk of rock and ice passing by, barely worth a headline. But then, over the course of just a few hours, the data changed. The object's path curved ever so slightly, as if something out there had pushed it. The room went silent. These were scientists who had spent their careers reading cold, predictable numbers, and yet the numbers now told a story that made no sense. They checked the instruments, recalibrated the sensors, blamed software errors. Nothing fixed it. The movement was real. Atlas was no longer following a gravitationally natural path. Something, or someone, had altered it. Across NASA's deep space network, dishes in California, Spain, and Australia locked onto the new coordinates. Every antenna pointed at the same dark section of space. The telemetry feed showed the object slowing down, rotating, and then accelerating again, not randomly, but with purpose. It was as if the object were aiming. At first, analysts thought they were watching a natural breakup, pieces separating under heat or spin. But the spectral data revealed a smooth, geometric surface flashing beneath the debris layer. The realization hit them all at once. This was not a typical comet. Inside the Jet Propulsion Laboratory, project leads argued whether to release the data. A few voices said, wait until confirmation. Others insisted the public had the right to know. Behind closed doors, a small team began running gravitational simulations. If the new vector continued, Atlas would pass directly through the plane of our solar system, crossing Earth's orbital path within the decade. Not on a collision course, but close enough to change tides, magnetism, and possibly even the stability of near-Earth satellites. As the calculations grew darker, NASA initiated a quiet request to observatories around the world. The European Southern Observatory in Chile, the Keck telescopes in Hawaii, and the Webb telescope all turned their gaze toward the object. Webb's infrared sensors pierced the dust and ice that hid its core. What it saw shouldn't exist. The signature wasn't a reflection of sunlight, but a radiance from within, pulsing in perfect intervals, like a heartbeat. Every 47 seconds, light flared from its center, then faded, again and again. The scientists began timing the pulses, converting them to frequency bands, running pattern recognition software. The rhythm matched no known astrophysical process. One researcher joked it looked like code, until the timing shifted into a repeating sequence of prime numbers. The room went silent again. Prime numbers don't occur naturally in emission intervals. They are the language of intent. Webb's next image captured something even stranger. A faint halo of particles trailing behind the object, spreading outward as if guided by an unseen magnetic field. That halo formed a shape, not symmetrical but structured, like a spiral seen from above. When the image enhancement was released to the internal network, someone whispered, "It's changing direction again." By the following morning, the object's acceleration had stabilized. It was now heading toward the outer edge of our system, angling slightly upward, straight toward interstellar space. Back the way it came. Whatever had altered its course seemed to have completed its task, but the data didn't stop. Those pulses of light continued, and then the amplitude doubled, as if sending one last burst before vanishing. The last transmission Webb received was faint, almost lost in cosmic noise. Hidden within the final burst was a modulation, a brief, repeating signal, compressed into a millisecond of light. Analysts stretched the data, decoded the frequency spacing, and when the visualization appeared on screen, no one spoke. The signal wasn't random. It formed a simple waveform pattern that resembled a mirrored sine wave, a reflection of Earth's own radio transmissions sent decades ago. The implication was impossible to ignore. Atlas had listened and answered back. NASA released only a short statement. 3I Tamiya Atlas has deviated from its initial trajectory. The object is now exiting the solar system. Observations continue. But off-record, researchers admitted that what Webb saw challenged everything we know about interstellar objects. For decades, humanity wondered if something out there might notice us. Now, perhaps, something already had, and it had chosen to move. Out beyond the orbit of Neptune, where sunlight is nothing more than a memory, 3 Atlas glides silently into the dark. Every 47 seconds, a pulse still flares from its surface, like a cosmic heartbeat fading into infinity. Somewhere inside that cold, tumbling fragment of metal and ice, an echo of our own signal travels with it, proof that in the vast silence of the universe, something watched, learned, and then turned away. And as NASA's instruments fall quiet, one question remains suspended over every mind that studied it. If Atlas changed direction once, who, or what, might be waiting for its return?